Welcome to the Professor's DuBois channel. This is Professor Corey, and this video is the very first of a series of mini lectures based on our actual lecture. These mini lectures will include slides covered during class. However, this is in no way meant to replace lecture. It is designed to summarize content. So let's get started. The scale of chemistry. We can think about chemistry in terms of scale or size. From the diagram, you can see that chemistry is considered nanoscale, which is really small. So small that we cannot see atoms with our eyes alone, or even with the use of a microscope. Notice the scientific notation and units above the images? Each multiple of 10 is called an order of magnitude. See our video on scientific notation if you need a refresher. Here are some of the definitions you should know. Be able to characterize items as being on the macroscopic, microscopic, or nanoscale. Whenever you hear the word atom, element, or compound, we're referring to the nanoscale. Cells, on the other hand, would be on the microscopic scale because we can see them under a microscope. Pure substances can be either elements or compounds. A compound, by definition, contains two or more elements in a fixed proportion. There are a total of 118 elements that have been identified, 90 of which exist in nature, and the rest have been synthesized. Elements are represented by a one or two letter symbol. If there are two letters in the element symbol, only the first is capitalized. If you see two or more capital letters in a chemical formula, this represents a compound. To classify a chemical as an element or compound, a useful tip is to look for capital letters. Remember, an element only has one capital letter, where a compound will have at least two. Si is an element, CO2 is a compound, and P4 is an element. This one's tricky, but remember a compound is two or more elements combined in a fixed proportion, and P4 is just one element. Physical properties do not depend on sample size, and they can help us identify or characterize pure substances. Examples of physical properties are included on this slide. This is not an all-inclusive list of physical properties. Pure substances also have chemical properties, which often involve interaction with other compounds or elements. Flammability is a good example. A chemical change results in an entirely new substance. For instance, the burning of paper will produce some carbon dioxide, water, and some ash. In contrast, a physical change does not change the substance. You should be able to identify changes as either physical or chemical. Melting is a phase change. This is a physical property. Burning is a chemical change, and tearing paper is a physical change. A mixture is when two or more pure substances are combined. These can be categorized as either homogeneous, meaning the same throughout, or heterogeneous, which is not perfectly consistent throughout. Solutions are a good example of homogeneous mixtures. Mixtures have physical and chemical properties that are often different than the pure substances that make up the mixture. For example, a solution of salt and water has a higher boiling point than just water by itself. This is a flowchart that shows the classification of matter. Notice that the elements can be further characterized. We will cover this in detail in another chapter. Copper wire is simply copper atoms. This is homogeneous. Beer would be considered homogeneous traditionally, but today's New England-style IPAs do have a lot of sediment at the bottom. You could argue that this is heterogeneous. Cheap beer would be homogeneous for sure. Soup is heterogeneous, and the reason for this is that each spoonful of soup is not exactly the same. Particle diagrams are used to represent elements and compounds in different states. The examples above are all the gas phase because they're occupying the entire space. Notice the term molecule here can be applied to either an element or a compound. This slide shows a nice summary of the different uses of particle diagrams. Notice the solid phase is more structured than the liquid phase. You should also be able to look at a particle diagram and determine the phase, meaning solid, liquid, or gas, and you should be able to determine if the material is a compound or an element. Homogeneous and heterogeneous mixtures can also be represented using particle diagrams. This concludes Chapter 1, Lesson 1. This slide provides a list of concepts that you should be familiar with. I hope you enjoyed the video. Please subscribe if you would like to see more mini lectures.